So this topic covers plants in Wisconsin that are categorized as trees. This is not all the trees in Wisconsin. We've seen some in, for example, the legume family. We've got some members, the honey locust and the Kentucky coffee tree are trees you can find in Wisconsin. The conifers produce lots of our trees. So these are kind of trees in groups that have not really been covered yet, including this one on the opening image. This is an oak with very characteristic leaves and fruits. So let's start in with what a tree is exactly. We saw that in the conversation about plant habit. So a tree has a couple of characteristics. It is woody. And as we'll see, it contrasts with the other woody category, in fact, that it is tall. So a couple simple pieces of this definition for our local plants anyway. So tall, we're talking about greater than 15 feet tall or about 5 meters. This is an arbitrary cutoff, but it works pretty well. And just in general, there's some plants that don't strive to reach such heights, and then the ones we categorize as trees typically make it there. And then woody, I think it's easy to think of that as a more simple term, but of course we saw that as a little more precise definition for us in Wisconsin. These are woody plants are the ones that survive winter above ground. So if you think about a tree growing from one year to the next, and a herbaceous plant, let's draw some kind of underground storage structure. So if you have an underground herbaceous perennial, it could have a rhizome or a tuber or something that it grows back from. And in the beginning of the year, as this plant grows, the herbaceous plant, even though it might have some stored energy, has to start from the ground. So it can only get as tall as it grows in a year. And a tree grows year after year. So I'm going to draw in some arrows for the places and kind of indicate the height that this plant can grow from. So when it comes time to grow new branches, new leaves, new flowers in the growing season for a tree, it can start higher off the ground. So this tree didn't grow all of that at once. It grew up to different heights over time. What you see as a naked trunk usually indicates that some side branches have fallen off over time and kind of streamlined down to this single trunk in many cases. And then the growing action happens closer to the tips where the tree puts out the canopy and collects most of the light that's available to it. It actually ends up kind of shading itself. So it's pretty advantageous to have this single narrow trunk that's not doing photosynthesis on its own. And then the straight and narrow feature of this trunk also means that it's pretty structurally sound. So good support to support something that's so high off the ground. So we talk about trees, we can talk about how they get to be so tall. And we can also talk about some of their advantages. So trees are abundant in certain habitats. They typically do well in environments that have better precipitation. So they do well in our northern forests, or a little more precipitation overall. And not so much in like a prairie habitat, sometimes drifts over into less consistent rainfall. The abundance of the frequency of fires sometimes affects whether trees are growing in a place. So what do trees do well? Well, we think about them being tall. What do you get for being tall? Obviously, probably the first thing that people want to think about is the access to light. So if you are the tallest plant in your habitat, you're going to get the most light, direct sunlight right from the source. And any plants that live in your shadow are going to have to deal with whatever light trickles through. So that's kind of an obvious one. Other features, you can think about the ability to produce flowers from high above the ground, flowers and fruits. So as these new branches grow out, this is the younger part of the plant, the growing part of the plant. That's where it's going to produce its reproductive structures. And that means that if you are distributing a seed, draw a little maple helicopters here. if you're dropping a wind dispersed seed from high above the ground, the wind is better high up off the ground. It's also got a longer way to fall, maybe farther away from the tree. So this increases the chance of abiotic dispersal of seeds, and then also of pollen. So wind pollination is pretty common in trees, and air dispersed seeds also pretty common in trees. So illustrating here a few of our advantages here. So shading out neighbors, surviving the winter and still being tall, and then producing these structures that can pollinate over distances. So trees, you might not always think about trees having flowers. So if it's not a conifer, then it probably has got some flowers. And a couple of reasons we don't typically maybe think about tree flowers. First one is just that they're small. So if we have trees that are wind pollinated, they're going to be producing small flowers that are indistinct. They're not attracting any animals, so they don't have to be big and showy. They don't have to be good smelling. They can be really inconspicuous, and just sort of green colored here. And this oak, so a cluster of oak flowers here, maple flowers, pretty small. You can kind of see these are maple also, see the relative sizes of those. And I'd say probably the other reason we don't really think about these is that their flowering happens pretty early in the year. So at a time when you're not seeing a lot of green plants around, a lot of our trees are already pollinating. So we're talking about this in April. April is a time when you can pretty reliably go outside and see some of our trees already putting their flowers out, getting the reproduction on. Being wind pollinated is a nice advantage in cold times of the year. If you're producing wind pollinated flowers early in the season, that might be before the animals are active. It might be too cold for animals, maybe not too cold to move plant pollen around. So a couple of illustrations here of the male component of flowering and the female component. That's another thing we saw in wind pollination, the separation of male function and female function, separate male flowers and female flowers, sometimes on different plants. All that pretty widespread in the trees, I would say. And of course, tree pollen, if these are wind pollinated plants are some of the bigger causes for allergies. This is a chart from the UK, and just shows nicely, I think, this arrangement of different pollen, different trees coming into flower at different times of the year. And they kind of agreed to have ranges that don't always overlap and when their pollen is being released. So good for them, not great if you are suffering from allergy pollen, because it's in the air, according to their data, from mid-February to mid-July. And then after that, the grasses take over. So pollen in the air all year round, growing times of the year anyway. So if we group our trees together, trees are very widespread. There are lots of independent origins of trees. Evolutionarily, it's not so complex to become a tree. Trees take some structures that are already present in herbaceous plants, and they just emphasize the structural component. So for example, wood, we're not really going to go into the details, but the wood of a tree or a shrub, that's made up out of xylem, which is the water conducting tissue. So plants already have those. All flowering plants have this water conducting xylem. And if they're going to become woody plants, they just put more emphasis in that. They structurally arrange the xylem so that it supports a larger plant body. They survive the winter and so on. So it has happened multiple times independently. These are the families we're going to talk about, but in so many of these other orders that are on this tree, especially in the eudicots, you would find trees kind of scattered throughout. I don't really emphasize them so much in this class, but the basal angiosperms also have lots of trees. So magnolia is in here. Other ones, the cinnamon, pawpaw is in there, and so on. Sassafras, lots of plants that do have trees also in the basal angiosperms. So we're going to talk about these, and just also want to point out a few of them are little close relatives of each other. So Betulaceae, Fagaceae, Joglandaceae, these are all in Phagales, and mulberries, elms, and hackberries are all in Rosales. So we'll see maybe a little similarity among plants in those groups.